All right, so we're starting at question number 77. These questions are going to be connected to logarithms. It's important that you try to do your best to not talk over the video, so you have a resource to actually go back to. If you choose not to study this weekend, then you made a choice. But your exam's coming from these questions, right, for you to study and complete. My expectation is that you do the even numbers, right? That if you only do the odd numbers with me, like what we're doing, it is not good enough to study for a final. Yay? There we go. 77. You know what a logarithm is? It's another way to write an exponent. It's the inverse of an exponential. So when I'm evaluating a logarithm, what you're finding is the exponent. So in 77, what's the exponent? The base is 7. The answer is 1 over 49. So what must the exponent be on the base to give you that answer? And it's negative 2. Awesome. Skip down to 79. What's the domain of a logarithmic function? Just the domain. Do you know what a logarithm cannot be negative inside? Nor can it be 0. So when I look inside, what's the 0 of what's inside? Positive what? So the answer is it has to be 4 or greater, the domain. Because if it's 4, it gives you the answer 0, bad. And if it's less than 4, it gives you a negative answer, also bad. So what's the domain of this function? 4 to infinity, and it's parentheses because 4 is not included. All right, let's go through it. Logarithm. If I'm going to graph a logarithm, you first need to tell me the parent. So when I look at this, the parent is just log x base 2. You're not going to remember this because we did it today. You're going to have to study it. Remember I gave you a sheet, right? You could write stuff down on? Maybe not. Maybe yes. So, maybe this will be on your sheet. What are the parent points in asymptote for a logarithm? So 1 point on a logarithm is 1 and. It is the inverse, right, of an exponential. Another point on there would be the base, which is 2 and 1. And then the asymptote is x equals 0. Our function is f at x equals, and it's x plus 3, base 2 minus 1. Where do I look to see where x has changed? Inside the parentheses or outside for x? And it's the inverse, right, or opposite direction. So what am I going to do to all the x's? Subtract 3. For the y's, where do I look? Inside the parentheses or in front and behind? And it does what it says. So I'm going to subtract 1. 0 subtract 1, 1 subtract 1, and now I'm done. So negative 2 and negative 1, negative 1 and 0, and we have an asymptote at x equals negative 3. A logarithm is concave down. A logarithm is concave down. Does that remind you what the curve should look like? So we have 2 points. Can you draw a curve that goes forever? The bottom to the top, and it's concave down. What would an exponential be? Concave up, right? The difference of the curve. What's the domain of this function? Where's the asymptote, right? It goes from negative 3 to infinity. The range is always all real numbers. And what would you tell me the end behavior is? As x approaches infinity, the function approaches infinity. As x approaches not negative infinity, but negative, the function approaches done. All right, turn the page when you're ready. You have to have questions to practice. And the answer key will be there today. Oh, I did an even number, didn't I? Accidentally. Hey, why don't I do another one then? I'll do 81 and stick to the odd numbers. Oops. Here we go. So we'll do 81 because I don't want to be off track with even and odd numbers. So can you do this one for me? Can you identify the parent in 81? Y equals, what's the base of the parent? And I'm transforming it to what I see. So start with the parent. There are 2 points on that parent. 1 point for a logarithm is always 1 and 0. And the other one is based on the base. And the base is 1/2 and 1. I'm going to change these. Where do I look to see where the x is changed? Inside the parentheses or outside? And do I do what it says? Or the inverse, right? So what is it saying for you to do inside the parentheses? Divide by, what's the inverse of that? So I'm going to multiply every x times 3. What do you think 1/2 times 3 is? 1.5, 1.5? 3 over 2, right? And then 0 times anything, it just stays at 0. How about the y? Do you see anything in front or behind it? And for the y, it does what it says, and you have to go in the order of operations. It means you got to multiply first and then add. And I know you got to go. So you go when you got to go. Got it? It's still a little bit. Anyone else going to the film festival? All right. That's all right, Dan. Here we go. So what am I going to do the y's? 0 times 2 is 0, and then add 1, and it's 1. 1 times 2 is 2, plus 1 is, now we're ready. So 3, 1, 1.5, and 3. Notice this curve is going to be a little different, right? Because the base is a fraction. That's why it's looks a little different. The end behavior is different. And then the asymptote is at 0. So what does the base do when it's a fraction? It's no longer concave up, it's concave, no longer concave down, but concave up. But it still has that curve to it. The domain still goes 0 to infinity. The range is still all real numbers, but the end behavior has changed. So as x approaches infinity, this time f at x approaches negative infinity. So the right end is going down. As x approaches negative, not negative infinity, but 0. So as x approaches 0, the function's approaching infinity. All right, now turn the page when you're ready. Now we're going on to 83, hopefully. So, enough graphing. Hey, how do you solve a logarithmic equation? So in 83, you have a logarithmic equation. How do I solve it? Is I write it as an exponential. So in 83, how do I write that as an exponential so I can solve it? Let me remind you. What's inside the logarithm? X. What's the base? And what's the exponent? So what does x equal? And for a logarithmic equation, you have to go back and make sure it's not extra. So when you go back and plug it in, does it give you a negative answer or 0 inside? But you have to check. So that's a good answer. 85. In 85, how many logarithms do you see on the left? 2. In order to solve it, to write it as an exponential, you have to use laws or properties to write it as one logarithm and then solve it. So what's the property when you're adding and the base is the same? How can I write that as one logarithm? So for the x and x subtract 24, what am I going to do? I'm going to multiply them together. Do you see how I distribute when I multiply them together? That's x squared minus 24x. Next, I can now write it as an exponential. How do I do that? What's inside the logarithm? X squared minus 24x. What's the base? And what's the exponent? So now I need to know what's 3 to the 4. 3 times 3 times 3 times 3. What type of equation is this now? It's now a quadratic. To solve it, I need to make it equal to 0. Think, think, think. What are two numbers that multiply to negative 24 and subtract to 81? Or is it multiply to 81 and subtract to 24? Wow. Did anyone else get that like that? See how quick Rosie got that? 27 and 3. You know your times tables that well. And 27 must be negative and the 3 must be positive. So one answer, what is the 0 of the first factor? 27. What's the 0 of the second factor? What do I have to do now is plug it back in. Are any of these extraneous? Because negative 3 gives you a negative answer, right, inside the logarithm. So what's the only solution? All right, 87. In 87, do you know your laws? Your logarithm laws. Do you know that when you're dividing inside, you can expand this by subtracting? So 87, if it's dividing inside, how do you expand it? By subtracting. Let's look at 89. Thank you. Number 89 again. How do I expand this? Well, when I see dividing, what do? And make sure you write the same logarithm and put a subtract sign in the middle. So x squared and y to the 7th, we're subtracting using the same logarithm base. Next, what law do I use when there's an exponent inside? Where does that go? In front as a product, right? Multiplying, and it's done. What did I do? What? You don't see a 7 there. Let me just fill it in for you. There it is. Good job. Turn the page when you're ready. What question number are we on? Which one did I do? 89, 91. Here we go. Can you use laws to go in the other direction? So can you use laws to write this as one logarithm? So look inside the parentheses. When you're subtracting, what can you do? To write it. Excellent. And I'll do another law here. That 6 can be an exponent on z. We're not done yet. Do you see how we're dividing? Do you see the 6 is an exponent, right? Yeah. Next, how about adding? What can I do to write that as one logarithm? And when I multiply them together, see the fraction? Think of it as a 1 underneath z to the 6. In other words, the x and the z to the 6, they multiply, and then the denominator is y when you multiply them together. Excellent. How about some growth and decay questions? You ready for that? 93. Larry has $1,900 to invest and needs $2,400 in 15 years. Can you annotate with me? What annual rate of return will be needed to get in order to accomplish his goal? Now, for an annual rate of return, we can actually use this formula. And in this example, annual means once a year, right? It's compounded. What is our beginning amount? 1,900. What's our end amount? 2,400. And how many years? What's our T?
15.
So let's plug it in. So we have 2,400, 1,900, 1 plus, now R divided by 1 is just R, and 1 times 15 is just 15. That's what I'm solving for, the R there inside. So our first step is to divide by 1,900. And you can definitely simplify it if you want to. So divide top and bottom by 100. You get 24 over 19. Do you remember how to undo that exponent? How do I undo the exponent 15 to get R by itself? What's the inverse of the power? The root, right? And what root would I have? The 15th root. So it's the 15th root of 24 over 19. And then the last step to get R by itself is to subtract 1. Now, if you have an n spire, you have a root button where you can put any root in there. If you have an 89, you have to write it differently. You ready? So if you have an 89, you have to go 24 over 19, and then the exponent button. What exponent button means the same as, right? So if you have 89, you have to use that button. You have to write it as a fractional exponent. The n spire, can I just show you quick with the n spire? You can put any root in. Do you see the arrow there? Do you see the blue above the arrow? So if you press Control and the arrow, you can put any root in. But for the 89, remember when you're in calculus next year, you get the Ferrari, is that you can go 24 over 19, 1 over 15, and then subtract 1. Now, after you type it in, you have to write that. Oh, I didn't do it right, did I? So let's try it properly. It didn't look right. Do you know why it didn't look right? I needed a decimal answer. So let's do it correctly. So, do you see that decimal? How would you write that as a percent? So what rate of return do you need is 1.57%. All right, 95. What annual rate of interest, and again the word annual means n equals 1, is required to double your investment in 8 years? So we'll start with the same formula. Notice they don't give you any actual money. They just, whatever you put in, it's going to double. That means that when I divide by P, right? When I divide by P, A divided by P, no matter what numbers you put in, if it's double, A divided by P would always equal 2. So N is 1, so R divided by 1 is R. And then 8, T is 8, so 8 times 1 is 8. I want to know if you could solve for it, so I'm going to give you a moment. So we just did the math before. So do you understand if they talk about double or triple or quadruple, and they don't give you anything for the beginning amount and the end amount, that when you divide, that's the number you put in. So double means A divided by P would be 2. Triple would mean A divided by P would be 3, and so on. Now solve it. Hey, do you have a solve button on your calculator too if you wanted to use it? You want to try that button? Does anyone want to try the solve button right now? What would happen if you didn't bring your calculator on Tuesday especially? Or you don't even have like whatever to take it out, right? That's going to be your challenge, right? Got it. $2 a piece. Got money? Because the education I give you is priceless already, right? Come here. Hey, so I'll do it the other way. Just for fun, so you have it on the video. How would you solve it with your 89? You would press F2, and then you would go to solve, and then you would type in 2 equals, now I'm going to use x. So 1 plus x, close it, to the exponent 8 comma x. You could use R. It is on your calculator. It just takes more buttons. And then go diamond enter. And then what answer do you get? Notice they give you a negative answer, which I don't want. And what's the other answer? 0.09. What is that as a percent? 9.0. Correct? If you move the decimal, 9.05%. All right, 97. We're almost done this. And then you're going to have a chance to do what you need to do to study for your final. All right, 97. This is the one that Chris does really well. Do you remember this, Chris? Half-life. Remember how you did the setup for half-life? Remember how well you did on this? So, the half-life of silicon is 710 years. 50 grams is present now. How much will be present in 700 years? And round your answer to 3 decimal places. So, there are 2 ways to do this. I'm going to give you the short, here it is, direct method, right, to find half-life. So, the short direct method is using this formula. But the exponent, whatever the half-life is, it's going to be a fraction. So the formula just changes a little bit because we need a fraction because not every year it becomes half. Every how many years? 710. That's why we need a fraction in the exponent. Say, well, how much do we start with? 50 grams. Half-life means the rate is 0.5, and we're subtracting because it's decaying, becoming smaller. T, how many years? 700 years. And then what's the half-life? And that's it. In one step, you can do it. Now, notice the answer is going to be very close to half its size, isn't it? Because 10 more years, it would be half its size, right? So it's not quite half the size, but close. That'd be something worthwhile, right, to put on your sheet? Oops, I need to put parentheses around this, or else it will not be nice. So put parentheses around your exponent. If you don't put parentheses around that, it's not going to come out. It won't do the order of operations correctly if you don't do that. Do you notice it's really close to half the size, right? 25.245. All right, turn the page. This is it. Last half page to go. And then we've completed the odd numbers. You need to do the even numbers, no doubt about it. You might need to do more than this packet, right? You might have to go back to a lesson that you don't remember, know how to do. Here we go. Oh, the last page. Here we go. Can you try half-life again? The short way. So you try 99, I'll do 99. Good old Gretzky. Here we go. That's that guy up there, right? Wayne Gretzky, 99. You miss all the shots you don't take? Here we go. Isn't that right, Dahlia, in soccer? Every shot you don't take in soccer to try to score, you miss every one. It's like you, right? Same thing. So if you try to do something and they take the ball away instead of taking your shot the way your coach says, right? And you miss, the same thing, right?
Yeah.
But you never have a chance to score if you don't try to, Are we playing today?
Yes.
Nice. Jasmine, are we playing today? Nice. Did you know your teammates over there?
Yeah.
Is she nicer to you now?
She's always nice.
Oh, that's the right answer. Okay. Here we go. Who's losing today? Yaka. Yeah. You have to go there?
Yeah.
Oh, it's going to be a cold one. Here we go. Cold, but they might have had snow last night. You never know. That'd be fun, right? See snow on the sidelines? Canadian style. All right. Do you know how to set up Half-Life? I'm giving you a chance. Well, because this is your question, Chris, right?
Yeah.
This is it.
Yeah. That's the only question I'm going to
Well, at least you got one right. So, we started with 150 grams, 1 subtract 0.5. How long until there's 100 grams? Did you see the difference in the setup?
Yeah, you got me.
So what you're looking for here is what? Now, what I care about is, after you set it up, use your calculator, solve it. I care about the setup, and then use the calculator to solve it. Make sure you put parentheses. And again, I'm not going to use, I could use T. Do you know that T is right there, easy to use? So I could use T. T is a popular variable as you go forward in math because it represents time. Hey, did you get what I got? How many years it would take? So 988.587. Was this the nearest year? Well, that's silly, right? 989. Thank you. All right, here we go. 101. Now, the rest of the questions are a review of sequences and series. Write an explicit and recursive. Do you remember what that means? For the sequence below, and then find the 100th term. Now, 29 to 23 to 17, what type of sequence is that? Arithmetic? Why is it arithmetic? Because there's a, yeah, I like that, common difference of what? -6. So, do you know what the explicit would look like? It would be AN, and we'd start with -6, and then you could pick any term, but if you pick the first term, you'd have 29. What would the recursive look like? You would take the term before it, and what would you do? Do you see the difference between explicit and recursive? And then what are you asked to find? So I'm going to use the explicit, obviously, to do that. The recursive doesn't help you for 100 unless you know the 99th term. So plug it into the explicit. Use your calculator, obviously. All of these questions would be calculator-based that you get to use. I get negative 565. All right, skip down to 103. Hey, if I'm going to find the sum, I need to know the formula. What's the formula for an arithmetic series? So, how many terms you have divided by 2, and then it's the first term plus the... Now, what don't I know of those? I know the first term, I know the last term, but I don't know the n. Do you know how I'm going to find it? Take 393 and find what its term is. Now, what's the common difference here? 4. And then use the first term as negative 3. And now solve for n. And again, use your calculator. Press F2, solve, solve it. How many terms are there? Did you get 100 terms? Yes? So now what's the formula we're going to use in our calculator? 100 divided by 2 and negative 3 plus 393, and we're done. Use your calculator. So it's 19,000. 19,500. Did you get that? Turn the page. Now we're at the very end. The last page of the last page. Hey, do you know what a really, really good student was going to do that wants to get an A? Can I tell you this weekend? It's crazy. You will print this out again, all blank, and then you would do these again without me, the ones I did with you. I'm just saying, like a really, really good student, right? And you would actually first do your sheet, right? And then use that sheet with a blank one. It's crazy, I know. I'm just giving you, like, you know.
I mean, so it's a good idea, but you know nobody's going to do it.
It's an idea. I know football's on this weekend. You're probably cheering for the 49ers or something. Here we go. Wow, I saw that. A little twirl, too. And that little... So, 105, let's go. Hey, do you know what that symbol means in 105? Sigma, which means to add it up, right? Sum notation. What type of series is it? Arithmetic or geometric? How do you know? It's exponential, right? Not linear. So, I need to know the formula. So, the formula is, how many terms do you have? 6, big fraction line. It's A1. How do I find A1 in this? Plug in what number? 1. What's 1 take away 1? 0. 7 to the 0. 1. 1 times 5. So the first term is 5. Now what do I do in the formula? What's the base? Now your base is the same as what? And how many terms do you have? And then what's the denominator? Done. Use your calculator. So I'm going to type it in, diamond enter, and then what's the sum of it? 98,040. All right, 107. Again, sum notation. Again. In 107, stick with me for a few more. What type of series is that? That's right. It's an infinite what? Geometric. Is that a different formula? Infinite? It's easier. So for an infinite, what goes in the numerator? So what's A1? How do I find it? Plug in 1. 1 take away 1 is? Anything to 0 is 1. And 4 times 1? And then what goes in the denominator? And what's the base? Now, this would not work if it didn't converge. Why does it converge and not diverge? Because the r is less than 1. If it was bigger than 1, it would diverge, and there would be no infinite sum. It would just go to infinity. Okay, so go ahead. Use your calculator. And what's the answer? All right, let's do some stories. 2 stories and we're done. A small business owner made $40,000 in the first year and made an additional 6% over the previous year's sales. Find how much he made during his 4th year. Find his total earnings. Is this a geometric story or an arithmetic story? So the common ratio, 6%. Now, why am I going to put down 1.06? 6% is only the increase, but not the total amount, just the increase. We want everything, the increase and what it was before, both. So that's 1.06. So the formula would be, to find the 4th year, would be 40,000, and then the ratio, which is 1.06, and then it's n minus 1. So if I want to find the 4th year, I got to plug in 4. Don't forget that subtract 1 part. So 40,000, 1.06, and I'm just going to use 3. So, the 4th year, how much money? The 4th year was $47,640.64. Now, what's the second part of the question? What word do you see is total earnings? That means you got to add it up, right? And what's the formula to add up the first 4 years? Big fraction line. We start with 40,000. 1 subtract, what's the ratio again? 1.06 to the 4, and then the denominator, 1 subtract what the common ratio is. And now use your calculator. And I get the answer, $174,984. So the 4th year he made $47,640, and the total was $174,984.64 using both formulas. All right, here's our last one. Highway 111. Let's go. So let's go. Highway 111. Try it. Read it, annotate it, or last one together on the video. Can we try 111 first? And then, let's see, so you can go. And it's fine that you go. You felt bad at first, you were the only one. That just means you just say right? Are you Christopher Robin? Did I guess that wrong? You with who and Eeyore here and Tigger? Remember, Cristobal can tell your future. Oh, you like Krispy Kreme? I like he can tell your future. Cristobal. All right, 111. Let's go. Finish. Huh? Yes, the whole thing's on the video. Let's go. Someone has to get like 41 minutes into it to care about it. So, if I walk around, you're not done 111, you're not doing what I asked you to do. So annotate it. Is it arithmetic or geometric? And then finish it.
I'm great. She's not nice. She's getting it.
You have good math skills. Halfway.
Yes.
Very good.
So when I'm actually, I think it's... Shut up! But I have my calculations.
All right. A bicycle wheel rotates 500 times in a minute. If the rider stops pedaling, the wheel starts to slow down. Each minute, it rotates only 3/4 as many times as in the preceding minute. How many times will the wheel rotate in the 4th minute? And then after the rider leaves the pedals, round your answers to the nearest unit. Here we go. Hey, did you know if this is arithmetic or geometric? It is geometric. So if you're told, like, what's 3/4 of something, you are multiplying. What's 3/4 of 4? You are multiplying to get that answer. Got it? So, because you're multiplying, don't get too tricky here. The actual rate is 3/4. Because 3/4 is what's left over. That's what we want. Not the quarter. The 3/4 is what we want. And we're not adding. It's not summing. It's just the term. So, at first it went 500. That's your A1, right? Your first term. The common ratio is, and then the exponent would be n minus 1. So if I want to find the 4th minute without pedaling, plug in 4 and use your calculator. That's it. To the nearest unit. So in the 4th minute, how many times will the wheel rotate? 211. All right, that's it. Mr. G Math, over, out.